If the grass is wet, then it must rain. The grass is wet. Therefore, it must have rained. But the grass could be wet for any number of reasons, okay? It doesn't have to be rain, right? You can take your hose and spray the grass with it. It doesn't have to be rain. And the same thing is here. Just because human chromosome 2 may be the result of a fusion event doesn't mean that humans and chimps share a common ancestor. Okay, that's a logical fallacy. Casey Luskin, who is a member of the intelligent design movement, I think really stated this well, referring to Ken Miller's arguments on this. He said this: evidence for fusion in a human chromosome tells you little to nothing about whether humans share a common ancestor with living apes. The human chromosomal fusion argument focuses on a fusion event that is specific to the human line, and therefore provides a highly limited form of evidence for human-ape common ancestry. So he said, basically, even if humans diverged from chimps, okay, this happened once they were already on their own, okay, not back in the common ancestor, because again, chimps still have 48 and we have 46. So it happened somewhere after we diverged. Now, of course, from a biblical creationist standpoint, we would say there can be no evidence for shared ancestry, because again, God's word makes it clear that chimps and humans are in no way related. They were separate creation. So Luskin goes on to say, all Miller has done is documented direct empirical evidence of a chromosomal fusion event in the human line. But evidence for a chromosomal fusion event is not evidence for when that took place, nor is it evidence for the ancestry prior to that event. It doesn't tell you when it happened. It doesn't tell you what was going on before it happened. And so again, it's very much historical origin science, so our presuppositions play a huge, huge role. What is our starting point? Man's ideas about the past or God's ideas about the past, and what God's word says? It makes a big difference. And in fact, even those in the evolutionary community realize the problems with equating molecular similarity to evolutionary relationships, that if we're really similar, well, we must have diverged from one another. And these next scientists, I'm going to quote, think orangutans are more closely related to humans than chimps. And they said this: Schwartz and Grierhan contend that the clear physical similarities between humans and orangutans have long been overshadowed by molecular analyses that link humans to chimpanzees, but that those molecular comparisons are often flawed. There is no theory holding that molecular similarity necessarily implies an evolutionary relationship, even though that's what you hear all the time. And molecular data that contradict the idea that genetic similarity denotes relation are often dismissed, which is plain out bad science. They're just going to dismiss it. If it doesn't fit their theory, it's gone. And so they're challenging that. They're saying, you know what? Just because they're molecularly similar doesn't mean that they have a common ancestor, doesn't mean that they have this evolutionary relationship. So even they themselves are questioning this. And there's other problems with this as well. If you're going from chimps to humans, and we're supposedly more highly evolved, but this is involving a loss of information, okay? When you fuse two chromosomes, and it's obvious by looking at this, stuff is gone, okay? You've lost some of the centromere, and you've lost some of the telomeres. And those are very important. They're not junk, even though you see that a lot, and we'll talk about that a little more later. Some organisms have genes in their centromeres. Telomeres are very important in regulating the production from other genes, so they're very important. How do you get from one organism to another organism by losing information? You don't. It's a clear problem that we see over and over again. You need a game. And it's not a simple fusion. You know, a lot of people, I saw this one diagram where they literally showed, the two chimp chromosomes coming together and boop, forming a fusion. Oh, wow, look at that. And to, a layperson looking at that, they would probably think, wow, yeah, I can see that. This one was unfortunately used to teach children this, because this is what your kids are going to start seeing in their textbooks, and this is what they want teachers to teach. But it's not a simple fusion. There's a lot of non-alignments, gaps, and what we call translocations, pieces from other chromosomes. It's really mismatched. In fact, there's 150,000 base pairs that are in the human chromosome that aren't in the chimp chromosomes, okay? Huge parts are missing. It's not just a simple fusion, so don't be deceived by that, because that's what you'll see a lot out there on the internet. But what can we say about this? Okay, first of all, human chromosome 2 fusion event is not evidence for human-chimp ancestry. That is a logical fallacy. Right? Just because the grass is wet doesn't mean it rained. And we're going to keep going back to that, so keep that in mind. All humans have the same chromosome 2, or very similar chromosome 2, which supports that we all descended from a common ancestor, okay? Adam and Eve. There is disagreement, however, as to whether chromosome 2 is a result of a fusion event. People are still investigating this. Creationists are looking at this. Evolutionists are still looking at this. We don't really know for sure even if it's actual fusion of 2 chromosomes at some point in the past. So that's still kind of up for grabs on that. But again, we can say that this has nothing to do, it is a logical fallacy to think that this has anything to do with human-chimp ancestry.
Welcome back to Truth Seekers. The phone numbers are up there, so if you'd like to call, you can, and talk about anything relating to spiritual, philosophical questions about why we're here, where we're going. Is there evidence? We believe there is, especially fulfilled biblical prophecy, which really ties it all together. Vern, would you like to say anything based upon what we just saw, or would you like me to read something from an article here?
Well, she's speaking in an area that's a long ways from my expertise. So as far as the DNA and all the little bits, I followed some things, but not this particular discussion. But let me say, throughout the world, humans are recognized for humans. Chimps are recognized for chimps. Apes are recognized for apes. Orangutans are recognized for orangutans. Monkeys are recognized for monkeys. And it seems interesting. Well, first of all, just what we really see on the ground with our own eyes, if you go to a zoo or whatever, there's such a gap between humanity and human life and the animals that we are claimed to have close relationship with. That I guess if you're wearing your knowledge in workman's coveralls called wisdom and common sense, you'd say it doesn't just add up immediately.
It obviously doesn't. By the way, that Dr. Barney Maddox is his name, who in 1986 read his first creationist biologist article and started to have him question evolution, points out that, you know, besides the 4,000 diseases that they know come from genetic mutations, there's nothing beneficial. There's only one, he calls it semi-equivalent, or not uni-equivalent, but equivalent, which evolutionists tried out all the time as a beneficial mutation, which is that if you have sickle cell anemia, you're less likely to get malaria if you happen to live in a country that has mosquitoes carrying malaria. But sickle cell anemia, if you have it, you're not very, yeah.
It's the difference between living in the Congo in Africa or living in Washington, D.C. When I was living in the D.C. area, I was at the University of Maryland, I read the Washington Post regularly, and there were often articles about the troubles that people had with sickle cell anemia. So if you're in an area where it's not infested with the Anopheles mosquito and you're getting malaria all the time, you don't want it for sure, because it leads to a lot of physical ills. If you're in the jungle and the Anopheles mosquitoes are everywhere and malaria is knocking people down right and left, then your chances of survival are much better. But is that really an improvement? It gives an ability to fend better in a local, very dangerous environment. But in general, no. So, in fact, can you say it's an improvement? Globally, or in the larger picture, no, not at all. But in one small little niche, maybe so. And that's typical of what you get with the kinds of mutations that are often discussed with bacteria, or you say certain things evolve certain diseases and so on. They may change with mutations, viruses, and so on. But in fact, they're losing information, and it's the ones that the ones that survive are only able to survive in a more narrow niche, and so in the general situation, they're not so able to survive. So it's not really improvement. It's a downgrade.
Absolutely, and that's what they call beneficial.
Yeah.
I mean,
not beneficial.
That's no evidence for evolution for beneficial mutations, which are needed if you're going to go upward in evolution. You need lots of positive changes. That's the best they can come up with.